Yeah. Now we have all three equations, the equations of the loops, which looks like a system of linear equations, and actually it is. And remember the equation we have from the junction, that the sum of the current is equal to 0. We have that I1 minus I2 minus I3 is equal to 0. This is telling us also that I1 is equal to I2 plus I3. And what we're going to do is, let's take the first equation, this one. And this number here in particular is the one we're going to target, because if we substitute here I1 for I2 plus I3, we will have an expression in terms of I2 and I3, and we can use the second one and solve for one of the variables. It could be I1 or I3, I2 or I3. So let's go. Let's put here 24. Let's get rid of the units. Minus 4 times I1, and I1 is what? I2 plus I3. Minus 6 I2 is equal to 0. So then with this 3 of the 4 here, we will have what? 24 minus 4I2 minus 4I3 minus 6I2 is equal to 0. And then we have 4I2 and 6I2 is going to be negative 10I2. So we'll have 24 minus 10I2 minus 4I3 is equal to 0. Aha, got an equation here. Now, using the middle one, the equation 2, is right here, the equation 2, and the equation 2 it says minus 10 ohms. Let's put minus 10 volts actually, but let's put minus 10 plus 6I2 minus 2I3 is equal to 0. And what we're going to do is this. We have here a system of linear equation. We can multiply this one, the second line, by negative 2, and if we do that, we will get something like this. 24 minus 10I2 minus 4I3 is equal to 0, and negative 10. No, I'm sorry, it's not negative 10, it's negative 20, because we multiply by negative 2, so it's going to be positive 20. Sorry about that. It's positive 20. And negative 2 times 6 is going to be negative 12 I2, and negative 2 times negative 2 is going to be positive 4 I3 is equal to 0. And what we do here now is just add these two. 24 plus 20 is going to be 44. Minus 10 minus 12 is going to be negative 22 I2. Minus 4 plus 4 is going to be 0. It is equal to 0. Solving here for I, we will have what? 44 is equal to, well, we send 22, negative 22 to the other side. It's going to be 22 I2. We divide both sides by 22. And I2 is equal to 2 amperes. And voila, we found the first current. Right? We found the first current. Now what we're going to do is try to find I3. Now having that I2 is equal to 2 amperes, we can choose this equation to find I3, right? The only thing we need to do is just substitute. So it could be this one or that one, it doesn't matter. But we need to find one of those. Let's choose this one because it looks actually easier. Minus 10 plus 6 I2 minus 2 I3 is equal to 0. Since I2 is equal to 2 ampere, then we substitute here too. We will have minus 10 plus 6 times 2 minus 2I3 is equal to 0. So this is going to be 12, right? Minus 10 plus 12. And let's send 2I3 the other side. It's going to be positive 2I3. Minus 12 plus minus 10 plus 12 is going to be 2. Is equal to 2I3. So I3 divide both sides by 2, and we got that I3 is equal to 1 ampere. Yeah, we found the second one. And if you remember some of the loops, it says what? Current is equal to 0, that I1 minus I2 minus I3 is equal to 0, or that I1 is equal to I2 minus I3, actually plus I3, I should say. So I1 is going to be equal to what? How much is I2? 2 amperes. How much is I3? 1 ampere. I3 is equal to 3 ampere. So we got here. I1 is equal to 3 amperes. So we got all the currents. And if you look this one with the example that they did on the PowerPoint, yeah, you get the same answers, except that they use a different direction of the loop and they get in negative values. If you use the one that I did, you always get them positive, right? If you look at the answer, because they choose this direction of the loop, assuming that it goes here instead of using the one that I use. The one that I use, it will give you the positive values. And if you get a negative one, it means that the polarization was the other way around. Okay, guys, I hope this helped a little bit. I know it's a long problem. It took me like 3 videos to solve this one. And, well, okay. But I hope you understand. If you have any question, just send me an email. Take care, guys, and see you next time.